Hi everybody, welcome to dcr.py. In this video, we'll show you how to validate PDs. Let's get started. In this video, we'll show you three things. First, we'll discuss default outcomes and probabilities of default. Probabilities of default are also known as PDs. Second, we will estimate logistic regression models for PDs. And third, we'll use the estimated logistic regression models to fit PDs. Let's get started. We now validate our probabilities of default using the function validation, which is included in our program dcr.py. The validation function provides 4 panels as output. It includes a summary table of validation metrics in the upper left panel, a real fit diagram by time in the upper right panel, a histogram of fitted values in the lower left panel, and a real fit diagram by deciles of fitted values in the lower right panel. In our first step, we show you how the validation output looks like for a perfect model. We call the validation function using the validation command with 3 input arguments, which are the estimated PDs, the observed default indicator, and the timestamp. In a perfect model, the estimated PDs are equal to the observed default outcomes, and hence we use the same object name as for the observed outcome indicator. And hence we use the same object, that is the default indicator, as the first input argument. We then execute the code by pressing Shift Enter. The summary table shows us a number of interesting characteristics, the number of observations that is used in the validation, the default rate, the mean of the estimated PDs, the area under the curve, the R-square, the Brier score, the log loss, and the p-value for the binomial and the Jeffreys test. We then see a perfect calibration here in the time series real fit diagram, as the lines for the outcome and the fitted variable are matching. And we see that the fitted values take values of 0 and 1. The calibration curve also indicates a perfect calibration for this perfect model. We now validate our results from the logistic regression by running the validation function for our estimated PDs and observed default outcome variables. We press Shift Enter and we obtain the validation output. We see in the validation output that the area under curve for our model is 73.34%, and we see that the binomial and the Jeffreys test have a p-value of 50%, indicating calibration, that is, the hypothesis of calibration cannot be rejected. The real fit diagram in the upper right panel shows a good calibration of the mean PDs to the observed default rates. The histogram in the lower right corner shows that our probabilities of defaults are, generally speaking, on the lower end of the spectrum 0 to 1. The histogram for fitted PDs shows that our fitted PDs are generally low, close to 0. The calibration curve in the lower right panel shows that the scatters as combinations between the mean PDs and the default rates for deciles of PDs. The calibration curve in the lower right panel shows the scatters between the mean PDs and the observed default rates for deciles of PDs, and these scatters are very close to the diagonal line, indicating a very good fit. This brings us to the end of our session today. Many thanks for watching. We hope you have fun with deepcredits.com, and we wish you a good day. Bye bye.